All right. Hi, everyone. I'm Ben. Thanks for coming and braving the fun snow sleet weather. We're going to do flow analysis and network hunting today. Can everyone hear me okay in the room, projection-wise? Awesome. Cool. Okay. Is everyone logged in on the workstations okay? Yeah. Wonderful. Okay. So first off, next slide, please. We want to thank David Wilbur and Willie Cooper-Sannon for helping us with content review and the initial outlines of this course. So, next slide. I'm Ben. I have a pretty eclectic set of interests. Technical-wise, I like malware, reverse engineering, network sensing. I also like self-defense and race car classes. Over here is Mike. Mike just got engaged. And yeah, Mike, what do you like? What do you do?
Concept. No. So I've been here about 2 years. I do a lot of NetFlow work, other network security stuff too. Largely for the sponsor, but also I work on some internal minor stuff. Talk a little bit more about that later.
Perfect. Thanks, Mike. So I'll be covering a lot of the intro things, and Mike will be covering more of the advanced analytics later in the day. Next slide. So we kind of want to know about you here. For the public release, this will probably be edited out by Zeno. So we want to know, why did you take this class? Do you have any prior experience with NetFlow? And how do you think you'll be using this as well? So about the class, we'll be covering a variety of things here. Next slide, please. So NetFlow data, the tools. We'll have two types of traffic we'll be looking at. One is the other is from the IPOC data. It's a West Point cyber hacking competition. There's a lot of very noisy traffic in that. We'll also be covering analytic tradecraft, situational awareness, and hunting analytics. Thus the title. All right. So for those who haven't or not particularly familiar, need a refresher, this is your important things of packet capture. The pink highlighted boxes is what we care about for the NetFlow. And that's primarily your source IP, your destination IP, what protocol it is, TCP, UDP, ICMP, flags, which we'll get to, and total length. So if you're unfamiliar with PCAP, only worry about these pink boxes, and we'll get into these, what these mean. Next slide, please. So in terms of TCP, you have primarily your source port and destination ports, and these flags, which are important for NetFlow. Urgent, ACK, push, resets, and bin. TCP, again, it'll do retransmission if you're unfamiliar with it, in case something is not sent properly or there's disruption. Next slide, please. UDP is more of a good analogy. We kind of throw a bunch of glitter at something. It doesn't matter if it gets there or not. You send a bunch of it. And this note that we don't have any flags. We just have our source port and our destination port. Next slide, please. So what's NetFlow? So NetFlow is all those pink boxes we looked at. Just that. Everything else is cut out. And the nice thing about NetFlow is it's much, much, much smaller than PCAP data. So I think some of the competition data that I converted was pretty big, about 80 gigs. And I got down about 300 megs or so, just NetFlow. Note this is binary. If you transfer it to ASCII to pump it into any kind of log consolidation tool, it is going to get bigger. But for all the tools in class, you're going to be doing it with the binary files. So next slide, please. So NetFlow is PCAP light. All you do is you're essentially just yanking out most of this payload information, and you just end up with these headers. So the final thing is you have your source IP, your destination IP, who's talking to who started, who's receiving, your source port, your destination port, the protocol. Primarily here, you're going to be looking at TCP and UDP. There might be some ICMP and some other weird protocols, but for 99% of the class work, we're dealing with those two. Any flags we look at, which we'll come into later when we start looking at IDS evasion techniques, time info, byte info, packet info, and ICMP info. Next slide, please. So, key thing, if you need to know what actually is being sent, the actual application, what website they're going to, you're not going to get that with NetFlow. You still need PCAP. NetFlow is your phone bill analogy. You can see who's talking to who, the duration, but you can't see the actual content of that conversation. However, it is wonderful for doing quick network triage and looking for initial indicators of interest. So, in terms of NetFlow versions that we care about, there's a fair amount, but we're really going to be only looking at version 5 and version 10. If you're curious about the unique details of every one, Wikipedia has really nice entries on them. You'll be hearing the words IPFix frequently here. That's what we'll be working with primarily. So, basic TCP connection. We have 192.168, 1.1, 192.168, 1.2. So this is your traditional TCP handshake, if you're familiar with it. One machine says sync, the other one acknowledges it, sync ACK. Original machine responds to that one. Some wonderful data gets sent over. More data gets sent back. Says, hey, I want to close the connection with the FIN. There's acknowledgement and final knowledge. So that's your basic TCP kind of handshake. So you have your handshake, the data, and then how it ends. Is there any questions on that? Everyone feel kind of comfortable, or you're unfamiliar with this? Okay? Thumbs up? All right, next slide. So there's two types of flavors of NetFlow. It's Uniflow and Biflow. So Uniflow is, you're going to see that NetFlow perspective on a per-device basis. So in the example we just shown, the first one's Uniflow. So that first machine, the one on the left, that's the flow for its perspective, and the machine on the right is the other perspective. So you'll see your source address, the port it started on, where it's going, timestamp information, number of bytes sent. The other type is Biflow, where that communication between two machines, that's expressed only as one flow. So you'll see things such as this arrow indicator. For certain applications, you'll see that, okay, it's going from this machine to this machine. And notice that it has all the total byte information. We have a little question on the bottom. It says, why don't size listed match up with the amount of data transferred? Can anyone answer that question?
It's the sum of the two transactions up there.
Yeah. Mike, is that?
Yeah, so it is the sum of the two transactions. Also, when you're looking at sizes in NetFlow, it's including the packet headers. So it's not just the payload content, but also the headers are included in the size. So
So don't freak out if you see that. Next slide, please.
I have a question. That arrow that was in the Biflow, does that indicate who originated the?
Yeah, so you'll see it on a couple of different tools. I think Argos does that. I think Rho does that. Silk is a
Silk's Uniflow.
yeah, Silk's Uniflow. I'll talk about that when we get to each tool. Because some of the other tools, they do their flags differently, and that'll be one of the nuances we'll look at. Next slide. Perfect. Cool. So architecture discussion. So here's very simplified topology here. You have your router, your internet, and your LAN information. So you can get NetFlow in a variety of ways. The simplest way that we don't particularly advocate here is you can do it on your router, and basically your router will pipe out a NetFlow file out. The other way you can do it is you can do packet capture anywhere around here to some box that's going to hold all your PCAP, and then on that box you then convert it to NetFlow with these tools using the offline analysis syntax. Then from there you can then take that NetFlow file, pump it out to an analyst workstation, pump it out to ASCII or any kind of log consolidation tool like Splunk, and go from there. The other nice thing, if you do your PCAP and then converting the flow in the same box, you can make sure all your timestamps are the same, things of that nature. Or if you want to later go back and kind of follow some unusual behavior you want to look at, you'll have the PCAPs there as well. Question?
Why don't you recommend getting it from the router, right?
A few things. I think, that's 2 or 3 slides in, right? Yeah, a few reasons. One would be you might be limited to what NetFlow formats you can export to. If you just get PCAP, you can export to any number of tools. So if you like Argos, if you like Bro, if you like Silk, it gives you that flexibility. Additionally, there's hardware considerations you should be aware of. Can your router handle that? That's a question. Next slide. So where are sensors deployed largely? There is hardware limitations, like I just mentioned. Bandwidth of the link being monitored, straight collection versus pushing analytics forward. That's the question is, do you want to do the actual processing on that machine where you're storing all the PCAP and NetFlow files, or do you want to push that somewhere else? Bandwidth back to the centralized processing storage, and passive standalone sensor versus getting NetFlow off routers argument we just kind of talked about. Next slide, please. So now we talk about perimeter visibility and the different ways how you can see this information on your network. Your bread and butter tap is right before your firewall. And this would get all the information of machines going out to the internet and back. Anything your firewall did not stop. So one approach would be you do a tap here, you get your PCAP data, and then you convert to NetFlow, and then you can do your analytic tools from there. However, you can't see any lateral movement from this machine to this machine. So next slide. And that's where enclave level visibility comes in. So say I want to send Drew a communicator IM of a video of puppies playing or something, right? That's not going to go out to the internet. That's going to be a local connection here. Or if I want to do Samba file sharing, for example, that's going to be from machine to machine. So if you were to tap up here, you won't see any of that. So what you can do is you can do spanning ports if you have smart switches, and then from there you can grab PCAP off your switches, convert that to NetFlow, and then add analyst tools. And the nice thing about that is you can see all these inner communications as well. So next slide. So HostFlow. HostFlow was developed by a good friend and colleague of mine, Joe Mansour. Give him a little shout out there. It's a MITRE-developed tool. Collects NetFlow-like data from the host itself. It's a little client that actually runs on Windows Host right now. It requires the agent on it, so you can put it on something like a VoIP phone or something of that nature. And it bridges the gap between that network and host. It allows visibility when deploying network sensors at the access layer, and when the access layer is cost prohibitive. So next slide.
Oh, I just want to point out that, so we developed this tool at MITRE. It's also been, the same concept has been developed other places as well. There's a couple of open source versions of this kind of tool. So there are other options.
Say one thing that this type of tool gives you that NetFlow doesn't is the linkage of the flow to the process, which is its most valuable feature.
Yep. So Drew said that the nice thing about NetFlow or HostFlow is it gives you additional information of the process that what started that flow. Was it?
Using the flow.
Exactly. So whether when IE started, Firefox started it,
And the user as well.
okay. Perfect. Thanks, Drew. Oh, you get any questions or comments, feel free to shout them out. Next slide. So this is what the host flow looks like. So from all your clients here to an analyst box or wherever you're doing all your central repository storage.
I'd just like to add that right here, if you click on your Windows clients, make your Linux clients dedicated. You're not going to get VoIP phones, you're not going to get printer, you're not going to get other embedded devices. So, it's partway there, it's not as great as fully censoring, by the switch layer.
Yeah. So in the event your switches can't handle doing, copying all their traffic from a span port, or you don't have the ability to do that, this is one advantage.
So performance here on the host being monitored.
I don't think it's too bad. What are they using? Is it?
We're running in production now. It doesn't have a huge user impact. So there's a little bit of performance. But,
Yeah, I think that has to do more with what T-Shark's memory leaks than anything else.
Yeah.
Yeah.
Don't know the exact number.
Very minor. That is.
And
Next slide, please. So, Mike, do you want to talk about flow sampling?
Sure. So this isn't in your credit notes if you're looking at those. I thought about adding this after we sent those to get credit. So routers do flow sampling oftentimes. And when I say flow sampling, I mean out of every N packets, they pick one and convert that to NetFlow. It's fine for NetOps if you're worried about performance, sort of what's running on your network, and is the network down. But it doesn't really help for security because you're missing a lot of data. So we talked about censoring at the enclave, right, at the switch level, or even using host flow. That produces a lot of network traffic. Even when you can the NetFlow, it's still quite a bit of traffic. And depending on exactly what kinds of analytics you want to do, you might be able to further condense that down by aggregating or sampling. And this is particularly important if you're at a geographically diverse enterprise. So you've got a site here and a site there, and you can't send all your data back to one central place to do analytics. If you want to aggregate your data down so you can send it back. So what are some ways you might be able to sample NetFlow? Beyond just sampling packets to create NetFlow, what are some other ways you can sample or aggregate or otherwise condense NetFlow? Now it's early. Anybody have any ideas? No? Okay. So here's some things I came up with. Now this is going to depend on exactly on what analytics you do and what questions you're trying to answer. Some options. You can collect only from end hosts in a given subnet, for instance. Maybe only your end and port host, your high-value targets or whatever. You can only collect only for limited periods of time. So sampling packets to create flows, you can sample flows themselves. So you create all the flows and then only send back one out of every end. There are things you just aren't going to care about, like you don't want to see the SMTP traffic to your mail server. Maybe you should ignore that. Don't send that back. Collect only reports of interest. So if you're particularly interested, say, in lateral movement and you want to look at the Windows protocols, NetBIOS, and SMB, maybe you just collect that traffic and you ignore everything else. If you've got a NetFlow sensor at a higher layer in the network, maybe you only collect down for client traffic or otherwise traffic you're not going to see with your other NetFlow sensors. Maybe you only report on new SIP, S port or DIP port pairs that you haven't seen previously. You only want to see new traffic to see if the host is talking to somebody new. We can aggregate into larger time spans. So I saw X flows that contain Y bytes and Z duration from this host to this host, yesterday. Again, it's going to depend on what questions you're trying to answer, what approach you take. But one of the arguments we hear too, well, I can't censor at the switch layer, or I can't censor my giant enterprises. Too much traffic. That's certainly an argument, but there's some intelligent things you can do to help deal with that.
How is the argument that there's too much traffic to collect or too much traffic to handle?
Both.
Okay.
The argument I hear from my sponsors is too much traffic to analyze and to shuffle around our geographically distributed enterprise. So that's sort of where this expression came from.
Next slide. All right, fun stuff, tool time. Anyone remember home improvement? Yeah? Okay. So we're going to look at a few tools. Next slide, please. So YAP, Silk, iSilk, Argos, and Bro. And like I said earlier, lab data is supplied from the iTalk competition. And there's fun port scanning, malware, C2C behavior, SMTP, HTTP, FTP, SSH. NSA Red Team was the bad guys for it, which is fun. Next slide. So here's kind of like a high-level overview of what we'll be looking at today and kind of the pros and cons of every tool here. YAP is nice because it has the ability to do deep packet inspection. POF, which is a passive OS fingerprinting, so it actually examines network traffic based on how certain machines respond to TCP requests or any number of things. It can a fairly accurate fingerprint of what machines are on the network just by a discrete view.
Silk, can I just add the YAP API stuff? So it'll actually go into the packets and pull up metadata. So things like your DNS request and response, HTTP headers,
User agent strings.
User agent strings. So it's still metadata, but it's a much richer set of metadata than just your standard 5-tuple flow.
That's great pro for YAP. Silk, I really like Silk. I think it has some of the best documentation on it, analyst documentation, and the files stay in binary and they're very, very tiny, which is great. iSilk will be doing that as well. It's a very nice GUI front end for Silk, and what's useful about it is it gives you the actual command line or terminal commands that it's rendering all this with. So when I was first learning it, I used a combination of Silk and iSilk. So if I didn't know how to do something in Silk, I'd use iSilk, I see the thing, and then or the command it used, and I'd pipe it in. Argos, it's a really nice simple server client install process. There's many third-party tools that use it. Any modern Linux distro should have a package for it. YAF and Silk, we're going to have to compile from source, and the directions for Silk is pretty good. YAF and iSilk is, the directions could really be improved on. And then lastly, there's Bro. And Bro is an interesting, it's kind of like a hybrid IDS NetFlow piece. And it has this beautiful thing called a Bro Weird log, which is useful for picking up on strange evasion or indications that there's serious misconfigurations on your network.